Hi there, I hope you're well. This is Darren here, and within this course we're going to jump in to the New Zealand Standard H1 and look at some workflows pertaining to AS1. We'll also tag along VM1 as well because we can do that. Now before I jump in, as usual I'm going to reuse a model. This is a model that was generated using the geometry residential course, and this is representative of really what you will need to have in front of you to start using the workflows. Now should you want a copy of this model, you're more than welcome to request one. We can pop one into your account, but you'll need something, and it doesn't need to be this, but it needs to be a model set up using a NZBC workflow for housing, and this one happens to be placed in Auckland in climate zone 1. Okay, so for context, that's what we're going to be using. You might be using something in climate zone 5 or 6, that's fine, but this is all about climate zone 1, so we're based in Auckland. And we're going to be jumping into using these workflows over here. So once left clicked and selected, effectively the H1 workflows for schedule method, calculation method and modeling method can all be undertaken at the same time. But before we get into that, let's go ahead and have a quick look at the standard so we can re-familiarize ourselves with exactly what's happening over there, and I can talk to the approach that the platform has taken to meet these requirements. And here we are in the H1 Energy Efficiency Acceptable Solution document, and I'm just going to scroll down and we'll have a little look at the contents to start with. So yes, this is an acceptable solution, and should you want to go ahead and use a spreadsheet, you can also use a spreadsheet, but we think that is a complete waste of time, given that once you've created a model for AS1, you can do it for, you can run a simulation for VM1, or you can run it for overheating, you can run it for a daylight assessment. So it makes a lot of sense to pack all this into the same space, and you can even use our light plan now moving forward if you've got a very small home of 350 square meters or less. I say very small, it's not very small at all, but the size of the homes these days are getting so much bigger. So I'm going to find my way to this section here to begin a discussion. So section 2.1.1.1 really just outlines the methods that are included within this standard. So we have the schedule method and calculation method, which are included in subsection 2.1.2 and 2.1.3, and the entirety of the modeling method is detailed in another document, H1 VM1. The workflows that we have available on the platform meet all of these requirements. So you could surmise that even the details of this standard are not so interesting anymore because we've handled everything for you. So for example, in the schedule method, the glazing area is 30% or less. So this is, let me reread that. So in section 2.1.2.1, the schedule method should only be used where the glazing is 30% or less of the total wall area. So we do that check for you when you create your design. The combined glazing area on the east, south and west facing walls referred to Appendix D is 30% or less of the combined area of the total of these walls. We do that check for you. The skylight is no more than 1.5. You get the premise here. We go ahead and make sure that all of those checks are done for you. The second part is really just looking at those famous tables in H1 and seeing whether those values pertaining to construction thermal resistance or R values are being met. So really it's an elaborate lookup of performance values pertaining to so-called ceilings, walls, floors, or whether they're heated or not. And then you've also got the secondary table where we do not have the contained embedded heating systems, where we have even more values to look up. So we make sure that we go through a process of reviewing this on your behalf, so you really don't have to engage in what was the performance requirement for floor slab on ground within climate zone 6. Those days are gone when you're using the platform. Okay, so we do all that for you. When it comes to the calculation method, we go ahead and undertake the heat loss equations for the reference and the proposed building for you. Again, so you don't have to dive into that, and we look up every other rule within these methods in order for you to really focus on the design itself. Now let's have a quick look at VM1, so we may as well quickly contextualize that as well. And here is VM1, so I'm just going to go and grab that. For those that are familiar, and I'm sure many are, VM1 sits here as a verification method, not an acceptable solution such as AS1. So it is deemed to be a more detailed approach to modeling, and in some cases it's a more flexible approach. Effectively, the AS1 reference building that would be determined is compared to within this modeling method, and Appendix D is where all the details lie from a modeling methodology perspective. So in these sections here, D.1 all the way down to, and they go for some time, so flicking all the way down to the absolute last D.6 here. All of these requirements in terms of modeling method are strictly met by the platform in order for you to go ahead and provide a submission to council based on ASHRAE standard 140 that your process is deemed to be equivalent to this modeling process here on the screen, and that you have or have not met the minimum requirements of H1. So there is a real depth of information here that is all taken into account within the platform, and we'll go into a bit more detail as we start looking at a model. Back over in the modeling space now, let's do exactly that. Let's have a bit of a look at the model so we can understand what we're looking at. So this model here was set up with multiple zones. Strictly speaking, for AS1 you don't need to do this. For VM1 you do. Okay, and I've split this model up into zones for this lower level and also for the upper level. Okay, so we can hide the details there, see a bit more information here. So nothing too crazy going on here, but we do have a fully designed building ready to go. We're using tagging. Now, the tagging has been distributed primarily for the windows and for the doors. So those tags there, let's have a quick look at one, edit that. Windows 1 to 3 are represented by a triangle that happens to be green. And then that is distributed here with a performance value for the system R value, for the system solar heat gain coefficient, and for the visible light transmittance, or VLT. That is true also for all of the other tags that have been used to distribute the other glazing systems across the design. Okay. We have air walls. These have been included to create a boundary between two zones, but the boundary is effectively an air boundary with an air exchange rate of a default of 0.35. Okay. Now, should you want to go ahead and look at the window calculator, you can. Table E.1.1.1.1 within AS1, and if you wanted to generate your own values for your window performance, you can. We strongly recommend that you seek specifications from suppliers for these, but if you want to use this, you certainly can, and use this as almost as a conceptual tool to generate your window performance, and thereafter find yourself in a specification space. But this is effectively the lookup table within AS1. Okay. Now, when it comes to the zones in the model, I haven't done anything regarding the zones in this model, but what we must do when it comes to running a calculation for H1 is identify the zone that is not conditioned, and I'm just going to change the opacity of this garage zone because this is not conditioned. Indeed, I'm just going to change the color of it to a red, and I'm also going to do one more move here, and this is the critical bit here. We're going to go into the space settings, go to HVAC, and disable. Okay, so we're disabling that because we do not want an unconditioned zone to be a part of this model, because the thermal line is formed through that internal interface between the garage and the living space, the garage door and the garage wall there, living space, and this bathroom and the garage. So that is effectively the external line that is taken into account. So once you've done that, you're pretty much good to go. Now, all windows are going to be nominated with these tags here, and if they're not, we'll be able to identify that there's a window, an additional window missing from the tagging system. For the floors in this particular model, all floors are going to be modeled really as either a bottom floor or an external floor, and we'll have a look at this. But this bottom floor, we could say this is a slab on ground, or a raft slab, or whatever you want to call it, and save that. So we've updated that there so we can see this nomination come through. And for the external floor, this is where the internal floor is popping out to form I guess a feature within the design. So I'm going to go ahead and pull that up now so we're clear as to where that is. So when we look at the design here, that floor there is deemed to be an external floor. Okay, that is an external floor. So what do I call this? Level 1 floor overhang. Some terrible naming convention there. Hit save, done, and these here internal floor, well, that's just going to be an internal floor. So the reason I'm bringing all of this in is because we want this to appear in our reporting. So it's pretty critical that we get this stuff detailed up. Next up, we have roofs. Again, we're just using the default specifications for roofs. This is not to say that you can't go ahead and create your own roof. As in create a section of your roof and determine the total R value and bring that in here. I might bring in a wall that way actually in a second, just so we can see it. But here we have a couple of different types of roofs. So we have, and I'm going to pop this up here, the larger view, just so we can see it. We have a roof here that is fundamentally a cold roof system, and then we also have the same kind of cold roof system down here, and here we have a roof that has been I guess projected from the level below. So effectively we don't have a cold roof here, we have a warm roof system over here. Okay, so we want to make sure that these are all accountable. So the roof at the top is going to be that roof there, and I'm just going to call this cold roof system. Not a great name. And we're going to leave it as a value of 3.3. And then the typical roof, that should be the roof down there below there. And let's say I'm going to call that garage roof. Okay. And note that isn't above a conditioned space. So please do note that. And then that's now identified. And, you know, as long as you give these a name somewhere in this process, you're going to be in a position to actually identify errors in your model much more quickly. Now, for the walls, everything is defaulting to this value of 2 at this point in time. What I'm going to do, I'm going to create a secondary tag for the walls. I'm going to reuse an old tag that I'm not using anymore. Let's say upper walls here. I'm just going to put these at the top. Okay. And then I'm going to go to the first floor. And then I'm going to, what shall I do? How shall I select this? Well, there's so many ways to select it. I can, excuse me. Go ahead, grab that tag there, do it like this. And I'm just holding down Shift and dragging those around there like that. So they're all selected. And then I'm going to hit Enter and grab the upper walls there. Okay. Why that W16 is there, I don't know. Okay. And now what I've just got to do, just got to go step back over this one more time here because I've removed the tags for the window. So tags can always double up. I'm just zooming in and zooming out, selecting each one. No big deal. And those are now selected, and now we can double down on those tags and bring in that tag there, W6 to W15, to represent those windows. So those are now all in there. I think that's fine, happy with that. So what I want to do now though, I want to make sure we identify these upper walls with some performance values. Now I could go this route as a concept, but I don't want to. I could go this route as a template and maybe pick a template from a supplier. So go ahead and pick something from a supplier, bring it in, but I don't want to do that either. What I'm going to do in this particular case, I'm going to go ahead, I'm going to select concept just for a second so I can make my way to a save point. And then what I'm going to do, I'm going to go over here and I'm going to open up the project and create a new design for a wall, and that happens to be wall system 2, let's say. And I'm just going to pick a winner in terms of a template. There's other on-demand courses that will explain this process further. So there's a lightweight wall there. Happens to have a total R value 2.18. Hit save. Now I've had that save point confirmed there. I'm going to go back to the model. Go back to the walls, to the upper walls, remove that, and grab the design that I just nominated there. So that allows me to bring that directly into the model, and I can leave the internal walls at a value of 1 or something like that. Done. So that's also going to pick up on the nomination of external wall there. Oh, sorry, wall system 2. That's what it will pick up on. So we may have a bit of a conflict between the nominations of upper wall and wall system 2. We'll see how that looks. So we've got the roofs in there, the walls in there. I'm going to give this a title of generic wall, and that's really the lower walls. Internal walls, internal walls. Okay, these are all fine. Got some information in there. Okay, so there's a bit there. Skylights are skylights. Opaque doors are opaque doors. So we're kind of pretty well set up now to start having a look at the modeling side of things. So if we wanted to, we can run with this straight away. But before we do, just wanted to make a point of really what's happening here from a VM1 perspective. because there's multiple things going on here for AS1, VM1. From a VM1 perspective, the defaults that have been set up here for lighting and equipment and infiltration, etc., these are all as per the modeling method within VM1. Okay, so should you want to change these, you can, but to be very, very clear, the entirety of the default space setup for occupants all the way through to HVAC are as per VM1. The model is set up with something called ideal loads, which effectively just provides an infinite amount of heating and cooling for the space. You don't need to detail your HVAC for VM1, although it's always a good idea to have a look at it. Under the modeling, we're going to be just running a model, EnergyPlus 22.2. There's nothing here actually uber specific to VM1, but should you, VM1 or AS1, but you can adjust the EnergyPlus version. The step sizes, if you wanted to create a quicker model, you can run it every 60 minutes as opposed to every 15 minutes. Generally, every 60 minutes is fine for a small compliance model. You can change the solar distribution, which determines the complexity of the model for beam and diffuse solar radiation from minimal shadows to full exterior with reflections. We generally just default to the full exterior. But if you do have a complex building, minimal shadowing, it should help you in your concept design stage, and then you can move over to full exterior. Should you want to change the building rotation, you can do it under the simulation settings as well. Under site settings, we're defaulting to the latest and greatest NIWA climate data, but should you want to go ahead and use any of the other climate data provided by NIWA, or other climate files elsewhere, you can use those by simply selecting them here. Should you want to override the location, then you can also do that under site. You have an input for ground reflectance, which does make a difference, and you may want to change that. And for the temperature method, we default to the weather file, being the temperature method used particularly for the ground floor, but should you want to use a fixed method or a monthly average dry bulb, you can. We do not recommend it. The temperature is better to be sourced from the EPW file, which in this case would be the NIWA file. Calendar settings, not needed for H1. Zone settings, pretty critical in terms of making sure that your areas and your volumes are modeled as per your expectations, and this pretty much just allows you to subtract wall thickness, so account for wall thickness when calculating zone enclosed areas. Toggled on it does, toggled off it doesn't. Assign zone floor. When active, the floor area calculated during building synthesis is nominated per zone to EnergyPlus. When inactive, EnergyPlus automatically calculates the floor area based on the surfaces drawn, so we nominate that to be active. In terms of the zone volumes, again we have the account for the wall thickness. For the subtract floor thickness, account for the thickness of when calculating zones again. So this is all about just making sure that the accuracy is there in terms of the volume that's determined. Okay. Assign zone volume. When active, the volume calculates during the building synthesis. Again, similar to what was said before. When it comes to drawings, depends on your preference. Some folks prefer to draw the external line, some prefer to draw the internal line. This just allows you some level of control over it. So it determines where the external wall is positioned on your zone, which affects the calculated enclosed volume. So you can select to the external, select to the internal. It's defaulting to the center. And then finally, the thermal line here, internal top surfaces. So this determines whether a floor or a ceiling is assigned when the zones above are outside the thermal line. And you can either assign as a floor or assign as a ceiling. Generally speaking, you shouldn't really need to touch most of these, other than maybe changing your preference for how you've drawn the wall positions, I'd imagine. Finally, reporting. Should you want to change the format of the reporting, you can do so here by nominating these tags, and that will give you more flexibility in your reporting outcomes. Now, more specific to H1, we have a couple of inputs here. These are provided as a function of the understanding of the modeling methods. So the first one here is add resistance to unconditioned opaque surfaces. So when you have a look in the H1, I forget if it's AS1 or VM1, but you can account for an additional 0.5 R value in some cases. So if you toggle that on, that will appear, and effectively, let's say you've got a garage space, it's an unconditioned space, that will just dump in an additional phantom 0.5 R value to account for the low air movement within that space. Completely up to yourself if you want to nominate it. Allow custom solar heat gain coefficient when toggled. This allows you to determine the solar heat gain coefficient. In typical cases, we determine that for you based for the reference building, based on advice provided by MB and work undertaken by brands. So I should clarify, work undertaken by Wagans, and I think brands were involved as well. Again, generally you don't need to do that. We'll determine what the reference building is for you. By not toggling it on, it means you can have a consistent approach. By engaging in this means that you're effectively going to be creating a reference building with some, I guess flexibility in it. Let's put it that way, which may lead to inconsistencies in method moving forward. So we default to that being off. And then for the ceiling edge resistance, when active, determines an area weighted ceiling R value per zone in accordance with the allowance in note section 2.1.2. Again, should you want to engage in that, you can, and then you'll be able to nominate the method here. Again, we default to all of these being off. And I think that's about it. So let's say we're happy with what we've got here. We're happy with the representation of the modeling, and we want to have a quick first stab at seeing what the results look like. So the first thing you want to do is make sure the inputs are correct. And there's no reason to model any more than one building to do that, or sorry, one workflow to do that. So I'm going to hit schedule method, and I'm just going to run that. Schedule method, thankfully, is being removed from H1. It's not a very good or reliable method. And I'm not going to talk to any of the outputs yet. I'm just going to talk to the inputs, because this is the important bit. If you go to view details, geometry, you'll see the geometric representation of the thermal envelope, under thermal envelope. And first of all, you've got to agree, hey, this is exactly what I expect the thermal envelope to be. So the garage has been taken out. The cold roof there has been taken out. But we have a full ceiling height here in this space at the front, because we've combined the volume of the lower area and the roof system. So we've got a full height system there. For the walls, we have the 2.18s at the top. We have twos down below. We have internal walls at 1. For the floors, a couple of different floor systems here. So we've got the floor on the ground at 1.3. We've got the floor between the garage space and a bedroom space up here at 2. But then the internal floors at 0.3. And then this overlapping floor here of the level 1 to the outside is also 2. So there's quite a bit of detail there that needs to be understood, whether that's correct. For the ceilings, we've got ceilings at an R value, total R value of 3.3, and that's including the thermal bridging there. We've got roof systems that are really just metal sheets, so they don't actually have any thermal performance because these are cold roof systems, but this one down here, it does, because this is part of the thermal line, so that is has an R value of 3.3 against it. You'd want higher, of course. None of the values that I'm presenting here are deemed to be appropriate for design. They're just values that happen to be in the model. For the glazing, I think we have the same glazing throughout, so we've got a R value 0.29, I believe that's true, throughout, and you can go ahead and check all those out. So getting to the point where we go, okay, this is fine, this feels like it's appropriate. We've got the glazed doors there, and the opaque doors, okay. So you've got opaque doors inside the building which have no impact on the thermal performance of the design. These are only there should you need to run an airflow network. And that's a more detailed assessment of the infiltration and exfiltration of the space, and also any operability for the windows. And then you've got the performance of the garage doors. Again, we don't care about garage doors there. And then finally, we have the skylight. Okay, so there you go. We have the skylight there. And we have the nomination of the skylight. So that's fine. That's all pretty interesting. But really what we want to do is go under reports here and see the thermal envelope, because this is where we're going to get more detail about the inputs. And this is when I was nominating things like generic wall and wall system 2 and slab on ground and level 1 floor overhang. This is the value that is determined when you add that information into your model, because then you know exactly where it's being where you've nominated a specification, and that it's and then if it's correct or not. So I can see something there straight away that I'd be scratching my head thinking, oh, concept, what is that? Concept window, I don't like that. Concept window is not part of the window schedule. So I'm asking the question, well, what is it? It's a significant area, 13.4. I'd want to resolve exactly what that is. Also have some other concepts here, which effectively means that they haven't been nominated with a tag or with a title. They're just defaulting to whatever was in the model. So I would say there's a couple of things here for me that you'd want to clear up. Would be the removing the concepts, and we can have a look for this window. It shouldn't be too hard to find. 13.4, that could be multiple windows, but let's go and see if we can find that before we jump into any further. So what have we got? First of all, have we got all windows tagged at this point in time? Could be those sliding doors there. Could be. Let's see. So we seem to have these all tagged there, and I believe these are the sliding doors. So those sliding doors are brought in over here under glazed doors, so they are already nominated. So where is the glazing that hasn't been nominated? This is probably not the best way to do it. This is a better way to do it, actually. So what we can do here, and just a bit of a trick here, I'm going to change the value to anything, okay? And because I know that this is the only one that is deemed to be the concept because it has no title, if I go ahead and rerun the simulation now, all I've got to do is go to the front end results and grab a value, or grab the area here. Let me see. So this is now updated 0.54, but I want to go into here and see where that is. So we can see that they are down here. So it's just these two windows here. So really that's just an error. So I'm going to remove the glazed doors from there and bring those glazed doors back in here. And that's all that's going on here. So once I bring these in here, effectively just save that at whatever it is. Effectively what's going to happen now is that the concept, or sorry, the default here will no longer be in use at all, because all windows have been tagged with one of these tags. And now that's in play, we should see SD2 and SD3 come into play within the results. Now, I'm spending a bit of time going through this because it's important to get a feel for the results. To make sure they all make sense. And that all makes sense now. So then it'll be a pattern of just making sure that the rest of them are understood and accepted before we start looking at results. So let's navigate onto results, and I'm just going to run all H1 methods, schedule, calculation, modeling method, all at the same time. I'm not concerned about which one I want to do, because I can do all three at the same time, and these are going to pop up as we go. So let's look at the schedule method first, and this is it over here on the right. So green means good, I guess. It's a positive message. It's saying that you've met the requirement. Pink is a negative. It's saying that you haven't met the requirement. So if we look at the max total glazing area, that happens to be 97.49 as a function of that 30%. We're down at 50.39, so, or 36, great. For the max skylight area, 1.96 versus 1.35, fine. For the max glazing in south, east and west, 63.15, we're down at 18.99, fine. Wall area, an R value of 2 is required. We've got an R value of 2, great. But then we start to jump off here. The questionable 6.6 construction R value for Auckland is a requirement of 6.6 in the schedule method, but we've only nominated 3.3. Again, I'm not endorsing 3.3. I'm just stating that this has not been met. Same is true for floors other than slab on ground. 2.5 was the requirement. 2 is the specification. For slab on ground, we have 1.5, and I've got 1.3 here. One point I do want to make here is that for slab on ground to be determined, you need to have a high density slab, and it needs to be ground contact. Okay, it must be ground contact. So in summary, you can go ahead and look at this under results, and you see your ticks and your crosses, and this provides you with a summation of whether you comply with the schedule method or not. In this case it hasn't, so let's move on to the calculation method, where we use exactly the same kind of color referencing system, and we can see quite a different result when we look through this. Obviously we've got the heat loss for the reference building and the proposed building calculated for you to see. And we've actually met a lot more of the requirements, because you've got that 50% kind of backstop available in the calculation method, but we have not met the heat loss. So the requirement was 423.59 watts per Kelvin, and then we have a performance value of 431.46. In other words, this value here is not smaller than this value, so we haven't met the requirements. So we know that there's a challenge there. So it may mean that the modeling method is something that we can look at, and in this case that happens to be true. It looks like there's a positive outcome in the modeling method where the calculation method and the schedule method have both failed. That's not always going to be the case, trust me on that one. But if we go into the modeling method now, we can then dive in and see the summary, and you'll see a much vaster depth of information here that provides a summation of all inputs and outputs pertaining to the modeling, and it's very detailed, and this is becoming the standard approach in order to assess the requirements, which is the annual space heating load and cooling loads. Effectively what all of this says is that there is a simulated 26.94, and the target is 36.58 for the space heating and cooling loads. So the criteria has been met. So that's all fine, and that looks like it's very much based on, if we look at the heating is twice as high in the proposed design, but the cooling is twice as low. So it's kind of balanced out there, and it's allowed us to meet the requirements. You can navigate to view reference building or view proposed building, and you can also, if you want to look at the geometry of both at the same time, you can compare geometry. Now I'm going to go into the proposed design, and let's say we're ready to accept the specifications that have been set here. We're happy with the site location. This has all been done for you. You don't need to engage in any of that because we know where your climate zone is as a function of your geographic location. Should you want to even look at HVAC zone sizing, you can on a zone by zone basis here. So this is where the VM1 process actually provides a much greater value add than the calculation method or the schedule method, and is well worth looking at. And once you get into zones here, this is where things start to get a lot more interesting, because you can go ahead and start looking at the distribution of losses and gains on a zone by zone basis across the model. And while that's kind of interesting and it's a bit of trivia, and you can go ahead and copy that data out as images and bring that into your reports and into your presentations and such, you can also then go to other aspects of zones, such as zone solar loads, which then provides an interesting way of appreciating whether there is going to be any overheating, and that there is a bit of a classic profile for overheating in the shoulder seasons. So we can see it down there because you've got the two large glazed windows and they happen to be facing towards the east, I'm guessing. No, they're facing towards the north rather, not the east, the north. And that's because the sun is kind of coming around at this angle here, and it's really hitting those windows pretty hard. So it'll be nice and cozy during those seasons, but maybe that could lead to overheating during those seasons as well. You can start looking at your walls or your floors in terms of the actual heat gain and heat losses. Again, more interesting, the windows, you can start looking at the amount of heat gain versus losses, and you see, whoa, those windows there are getting a full hit of heat there, and the amount of heat transferred is significant, particularly as a function of solar gains. More shading would be a good idea for those windows there. I'm not going to go through all of these. Skylights, we can look at those, of course. You can look at all of these things. Thermal comfort, we can start having a look at what the distribution of PMVs or thermal comfort is within the space. I think probably operative temperature is probably a bit more meaningful from a VM1 perspective, where you can look at the operative temperature and see what the data points look like. And this is across the course of the year, and obviously there is a bit of a bias here because these operative temperatures are both driven by the internal assumptions and the external assumptions. So what I mean by that is that the internal assumptions are based on the method within VM1, and the external are based on the climate and the design, of course. So if you have two high loads or two low loads within the internal assumptions, then it's going to have a corresponding impact on the operative temperature. But even the time of day, the use of the building, etc., all has an impact over here. But what this is saying here, that there are a lot of data points where the operative temperature is below 20 degrees, which isn't what you want to get. You can look at carbon dioxide should you want to, and that's going to be more interesting if you've actually got an HVAC system specified. So there's a whole heap of stuff that you can look at, but when it comes to the summary, this is the important bit. Should you want to go ahead and copy this information out, copy it out. This is repeated in your report, but you get a summary of the heating load and cooling load. These are the big bits here, and this is the bit that you're comparing between the reference building and the proposed building. The reference and the proposed. So you can flick between those two and see what the difference is. You can look at things like electricity demand, heating demand by month, cooling demand by month, lighting, equipment, nominal loads for the zones. This is all so you can just check things out and look at meters per zone as well. So there's a whole depth of information available to you, and this can be taken to the next step where you accept the VM1 and it is what it is and you comply, but then you can go ahead and actually do a copy of this and actually make this into a real world model with HVAC systems in there and really optimize it to a much greater degree, do overheating analysis for TM59 for Homestar or daylight systems for Homestar, that sort of type of thing. So this is just a step in the process. But once you're happy, you're going to go ahead and, whether you're grabbing the schedule method, the calculation method, or the modeling method, but you're going to download your PDF. And once you do, you can add a theme, add your branding, or add on specific information about the project. We do encourage people to use this, although it's not as common as we would like to see, because what it does, it allows you to provide a much greater confidence to reviewers that you know what you're talking about. And this really, really helps. For some folk, they just directly use our reports and flick them straight over to the council and get them to review it. What we do recommend is that you use our reports as almost like as an appendix. You write a 2-3 pager based on the modeling that's been undertaken, so you're summarizing the report, and then stick the report in the appendix. And that is the best way to handle reporting with council, because effectively they want to see your competence. So I'm just going to produce that report now. And here it is. It doesn't take long to generate. You see the Better Building branding there. You can replace that, of course. But here it is, just a breakdown of the entirety of the modeling process from a VM1 perspective. So while this is well received from a council perspective, you can see that there is lots of information here in terms of what it's aiming to do. And in fairness, these types of reports, because they're generic in nature, will never be perfect. A bit like a building code, it will never be perfect. So we propose that you use these as an appendix, so you can then go ahead and say, hey, look, everything's been done here, but here is a summary of the report for you at council to appreciate. We know what we're talking about. And of course, when it comes to the I guess the competency around reporting with councils, we suggest that you use the certificate of competency that comes with this on-demand course, also within the appendix, to show that you know your stuff and you're doing exactly what's required by you. So there you go, we're back in here and we're going to wrap this one up. So there is a lot going on here. Generally speaking, you're never far away from, I guess, running multiple workflows on the platform when it comes to H1. The level of detail I've gone through here is arguably more than what many folks might be doing, but it does provide you with the additional value of being able to get more data out. And data is important to make a decision when it comes to designing buildings, because it's not just about ticking a box. It's also about making sure that you get solid outcomes for the occupants of the home. And in some cases, you're going to find that there is additional context that is provided through VM1, for example, such as overheating, that you can confidently talk to because you've got a model that has done the work. If you're just leaning into the calculation of the schedule methods, they're arguably going to ignore some fundamentals around design, particularly to do with the performance of glazing and solar control. So even if you're fully intending to just do the calculation method, just bang the modeling method as well, because it's going to give you the confidence to talk about these things when your client may not want to engage in them, but as long as you've kind of backed yourself up and you've made a point that there is a potential risk in certain designs, even though they've ticked the box, you've done what you need to do to cover yourself, and your client has been made aware of the risks pertaining to a design outcome that they may not be willing to budge on, but then that's at their behest. So there you go. Thanks a million for listening. I'll leave it there. Best of luck with it. Make sure you go ahead and use those certificates and pass the 80% pass mark for the Q&A, and I'll see you in the next one.